This is a video for the topic B5, homeostasis and response, looking at negative feedback. So we're covering a lot of ideas here that are found in other videos, but we're just kind of bringing them all together, looking at them in terms of negative feedback. Now, whenever you talk about any of these situations, if it's a 6-mark question, it's useful to identify that it is a method of negative feedback, okay, just to show that you understand what negative feedback is. And I always think of negative feedback is you go to a hotel and you have a bad experience, you're more likely to say something about it, give some feedback about it, than you would if you had a positive experience. That's just life, unfortunately. Okay, so negative feedback is our body is in a negative situation, we're feeding back some information, and then we're correcting that situation to improve, again, going back to homeostasis, those internal body conditions. So let's have a look at the first example. This is one that's for everybody, but it's so double and triple science, but it's looking at higher only in the way we discuss it as a negative feedback loop. So if we start at the top there, we've got too much glucose in the blood. So in this situation, the pancreas, which is the gland, releases the hormone insulin. And insulin converts some of the excess glucose into glycogen. We've got to be really careful with our spelling there. Glycogen, think it's been generated, and then that's stored in the liver and the muscles. That gets us back to that stable glucose concentration in the blood. It reduces that concentration. Then we move on to too little glucose in the blood. We're at the bottom of the diagram now. The pancreas, again, that's the gland, releases the hormone glucagon. Okay, we must get our spelling right on that one as well. And think of it as it's all gone, glucagon. Okay, and that converts some of that stored glycogen and it converts it back to glucose. And it's really important to say that glucose goes back into the blood. So that's our first negative feedback, looking at glucose control. Our next two examples are for triple science only. Okay, so we're looking at temperature control, where we looked at vasoconstriction and vasodilation. Again, we'll start at the top of the diagram. Okay, so we're looking at the left-hand diagram where it says too cold. So if you're too cold, blood vessels constrict. That's caused by the muscles either side of the blood vessel contracting. So it's all the C's together. It's cold. The muscles either side of the blood vessel contract. That causes the blood vessels to constrict. Less blood passes through those vessels, and so it's maintaining the heat that would be lost through that blood in our torso, in our main body there where all of our organs are. If we're too hot, then the opposite happens. Okay, the muscles relax either side of the blood vessels. These are the blood vessels we're referring to in our hands, our feet, our nose, our ears, that sort of thing. And when the blood vessels dilate, more blood passes through those vessels, so the blood gets closer to the surface of the skin and heat is lost through the skin in the hands and the feet. Okay, looking at the example on the right, this is our water control example using the kidneys and the pituitary gland. Okay, so if there is too much water in the blood, the pituitary gland, which is the gland obviously by the fact that it says gland, releases the hormone ADH. You can remember it as ADH. Remember, all of the hormones from the pituitary gland are abbreviated to letters, and ADH is antidiuretic hormone. What ADH does is it changes the permeability of the tubules that reabsorb water in the kidneys. So if the pituitary gland releases less ADH, the tubules in the kidneys become less permeable, and therefore less water is reabsorbed. So I'm going to say that again from the beginning. If there's too much water in the blood, the pituitary gland releases less ADH. That makes the tubules of the kidney less permeable. Therefore, less water is reabsorbed back into the blood. Let's look at the reverse of that, because this is a classic 6-mark question. If there's not enough water in the blood, too little water in the blood, so this is a day when we're dehydrated, the pituitary gland releases more ADH, more antidiuretic hormone. What that does is it makes the permeability of the tubules in the kidneys increase, and therefore more water is selectively reabsorbed back through those tubules into the blood to retain as much as possible. Okay, both of those, again, examples of negative feedback. The kidney one, there is a whole video on the use of ADH in controlling water content in the kidney. Have a look at that. And the final two examples then are looking at metabolic rates, and again we're now back to double science as well as triple. So there's two glands involved here, and there's two hormones involved. Okay, thyroxine is involved in metabolic rate. Okay, so if there is too much thyroxine in the blood, then the metabolic rate is in danger of being too high. The pituitary gland, so just to go back actually, thyroxine is produced by the thyroid. Thyroid in the throat produces thyroxine, and if there's too much in the blood, the pituitary gland, back in the brain again, but never say brain, always say pituitary gland, stops releasing TSH, thyroid stimulating hormone. So if there's too much thyroxine, we definitely don't want to stimulate any more production. So the pituitary gland stops releasing the thyroid stimulating hormone, the TSH, and less thyroxine is released. That one sounds quite difficult. I think it's easier when we look at the next part of it. So if we're at the bottom of that left-hand diagram, thyroxine levels in the blood are too low, so the thyroid in the throat isn't releasing enough thyroxine. The pituitary gland releases more TSH, more thyroid stimulating hormone, stimulates the thyroid to release more thyroxine and bring that thyroxine level back up. So I think that one's easier to understand, but then when we look at it in reverse, too much thyroxine, and the pituitary gland stops releasing the TSH, stops stimulating the thyroid to make more. And the last situation is looking at stress and looking at adrenaline, the fight or flight hormone. Adrenaline is released from the adrenal gland, which it's like an added on part of the kidneys. Okay, and the kidneys are referred to as the renal system. They're part of the renal system, so it's like an add-on, adrenal gland, okay, because it's part of the kidney, or attached to the top, I should say. So if there's a stressful situation, the adrenal gland releases adrenaline, and it causes the heart rate to increase, getting more glucose and more oxygen to your cells. If there's no stress detected, then adrenaline isn't released by the adrenal gland and your heart rate remains constant. Hope you found that useful. Thank you.